All right, for this one we're supposed to find the lateral area of this figure. So, and the total area and the volume. Okay, so the lateral area is pretty easy. That's just 7.2 times the length. This is like a can that's rolling down the cupboard, so it's about 198.9. Looks like 2 sig digs, so we would say 200 with a line over this first zero. The total area, we're going to add those two bases, so plus 2 times pi, and then r squared is 4.4 squared, and we get, ooh, what did I do wrong? Go to air. Oh, times 4.4 squared, and we get 321 is the total area. I forgot what the lateral area was, 199. And now the volume is the base times the height. So the area of the base is 4.4 squared pi times the height, which is 7.2, and we get the volume is 438 centimeters cubed. This was centimeters squared. Next one. This is an irregular shaped object, and the one that's pictured in the book, they give you the 60-degree angle, and so you have to, well, I'll just pretend that this one is angled that same amount. So let's say that this was actually tilted so that this slant height is 10 and this is a 60-degree angle. If that's true, then this would be 5, and this would be 5 root 3. So just pretend like this part here is bent over that far. So then the area will be, the area of the base, 15.5, I'm sorry, the volume will be 15.5 meters cubed, or meters, times the regular height. Since the slant height is 10, the regular height is 5 square root 3, and we get 134 meters cubed. Get the right number of sig figs when you do your problems. Next one. This is like number 5. Okay, so we need to find the volume of steel here. So what we're going to do is treat it like a subtraction problem. We're going to take the volume of the outer cylinder, which is half the diameter, so that's 1 squared pi, times the length, 3, and then we're going to subtract half the inside diameter, because that amount of metal was removed, 1 3/4. But remember, that's the diameter, so the radius is half of that, squared, times pi, times the length, 3, and so the volume of just the brass part there is 2.20 centimeters or inches cubed. Next one. This is the engine problem, like number 7. Okay, so we've got the volume of each cylinder. Now remember, those are 90 millimeter in in diameter, so they're 45 millimeters in radius, squared times pi, and there's the depth of each one is 95, so that's the volume of each cylinder, and since there's 4 of them, we will have 2,417,455. And if you notice in your assignment, it says that one liter is 1 million millimeters cubed, so we'll divide that by 1 million, and we get 2.4. It's a 2.4 liter engine, which kind of makes sense. Next one, this is the gas tank or oil tank. It's 5.21 feet across. Remember, you have to take half of that. So we're going to take 21 over 2, square it, times pi, times the height, 6.93, so it's going to be 147.7 cubic feet, times 7.48 gives us about an 1,100 gallon tank. Next one, this is the cone application. Let's see here. This is a right circular cone, and the circumference here of the bottom is 280 inches, and the slant, 28 inches, and the slant height is 32 inches. So I got that from the title of the slide. So since the circumference is 280, we want to know what the radius is. So we're going to take 280 and divide that by pi. Actually, divide it by 2 pi because we want the radius, and we get, so it's a 44 inch radius. Let's see, what do we want? What is the area of the lateral surface? Now, if you look at your formulas, the lateral area of a cone, right circular cone, is the side over 2 times the circumference of the base. Oh, I'm sorry, we could have just taken that, couldn't we? Sorry about that. The slant height, which we said was 320 over 2, and then multiplied that by, oops, let's split it up on top, times the circumference, 280, and the total surface area is 44,800 inches squared. That was a lot easier problem than I thought it was going to be. This one is like the next one, number 15. Each one of these sections is 10.0 centimeters. 1, 2, 3, 4, 5, 6. So it's 70 centimeters tall, and the diameter here of the base is 68 centimeters. So since we want the volume, we're going to use the formula 95, which says the volume is another fraction, the denominator of which is 3, but the numerator is the height, which we said was 70 centimeters, 10 for each one of these, 10, 20, 30, 40, 50, 60, 70, times the area of the base. Oh, I suppose you don't want it that way, you want it, I was just going to put them all over the same denominator, times the diameter, which is 68, but remember we want the area of the base, so we're going to take 68 over 2. That's 68.0 actually, over 2 squared times pi. And we get 84,000 centimeters cubed, 85,000 if you round to the nearest. Oh, we need 3 sig digs, so it's 84,700 centimeters cubed, because each of these dimensions are to 3 sig digs. This is the pole problem number 16. We want to know how many cubic feet are in this pole. Well, it's a 5-inch radius at the bottom. So we're going to take 5 squared pi and then well, I'm trying to use formula 97. I'll do it the hard way. You're going to take the height, so we have to go forward one picture. This flagpole here is 17.5 feet high. So we're going to take 17.5 times 12. We're going to get our answer in cubic inches. Divided by 3. So the formula says take the height divided by 3 times the product of the area of the two different bases. So the area of the bottom is 5 squared pi plus the area of the top, which if you look at my picture here, oh, where'd the picture go? The area of the top, which is 3 inches, is the radius, squared pi plus, and then it says the square root of the product of the two areas, so 5 squared pi times, 5 squared pi times 3 squared pi, close parentheses, equals 10,774 cubic inches. We're going to divide that by 1728 because there are 1,728 cubic inches in a cubic foot. So it's about 6 cubic feet is how much that flagpole is. Actually, it's not solid aluminum. That'd be a pretty expensive flagpole if it were. Next one. This sand pile is like number where is this one? Oh, find the volume of a circular cone. This is number 15. It says the sand pile is 6.25 feet high by 8.80 feet in diameter. So we're going to find the area of the base, which is 4.40 squared pi times the height over 3, so it's 6.25 over 3, and we get about 127 cubic feet is the volume of sand there. This one is like the sphere Find the volume of a sphere having a surface area of 462. We'll find the volume and radius. Okay, so the surface area is 4 pi r squared. So we're going to take this surface area, which we know. Okay, surface area is 4 pi r squared. 259 is 4 pi r squared. Oh, I know what I did. I did the cube root. Divided by 4 pi will be r squared. Take the square root of both sides. And you'll get what r is. Yeah, I had that. So it's the square root of 259 over 4 pi, and we get 4.53 inches is the radius. So then we're going to take that cubed, because the volume of a sphere is 4/3 pi r cubed. So now we're going to take it times pi. Oops. Times pi times 4/3, and we get 391, which is what I got doing it the other way. All right, next one. Now it says how many great circles of a sphere would have the same area as the surface area of this hemisphere. So in other words, if you take the surface area, or this area of this circle, which is pi r squared, that is the same as half the area of this half of the hemisphere, because the surface area of a sphere is 4 pi r squared. So since this is pi r squared, each of these halves down here would be 2 pi r squared, and then if there were a full sphere, it'd be the other two sides. The last one talks about the weight in pounds of these balls, and if you notice, it says they are 5.60 inches in diameter. So we're going to take 5.60 divided by 2, that's the radius, squared. No, we aren't squaring it, we're cubing it. Times pi times 4/3. So that's how many cubic inches each ball is. And since there's 5 balls here, times 5, we're going to have 459 cubic inches. Each cubic inch weighs 0.28 pounds. So this is how many cubic inches is. It is, so times 0.28 will give us 129 pounds of steel. This is the assignment that we just completed.